Example 3 gives us two inequalities, the first of which would be the graph of x squared shifted down by 9 units. Since we have a strict inequality, we'll graph this using a dashed curve rather than a solid curve, which again represents that the points along that curve itself aren't solutions that would make the inequality true, but does provide us with that boundary. The other expression that we have to graph would be a line passing through -6 with a slope of 1. In this case, that inequality statement is less than or equal to, so we would graph that with a solid line, and we could find by testing different points, for instance the point 0, -8, that all points above that parabola but below our line represent or are included in our solutions. So what we would be looking at would be that small shaded region, or that small bounded region, above our graph of inequality 1 and below our graph of inequality 2. In our last example, we have the graph of x squared and a circle. So looking first at inequality statement 2, we'll graph it in this case with a solid curve. And then a circle with a radius equal to 9. I missed my bottom point, but hopefully you get the idea there. And we should extend this curve up just a little bit so that we have that bounded region. In this case, we could use 0, 0 as a test point, and we would find that that makes both inequalities simultaneously true, meaning we would want to shade the region contained inside the circle, which corresponds to inequality 1, and above the parabola, which corresponds to inequality 2. In these last two cases, I've jumped, or actually in most of these cases, I've jumped straight to that solution. If 0, 0 wasn't a solution, keep in mind, your next step would be to choose a point outside that parabola, but still inside the circle on either side. We would have a region that's outside the circle and below the parabola, and then we would have a region that's outside the circle and above the parabola. So we have several different regions to test, but we can choose different test points until we find an XY pair that makes both of those inequality statements simultaneously true.